Radicals and rational exponents. Let's start with a quick warm up here. You guys write the first two in radical form and the bottom two in exponential form. Pause the video here, come back, see how you did. All right, welcome back. So 64 to the 1/3 power is the cube root of 64. Cube root of 64 is 4. 81 to the 1/2, anything to the 1/2 is square root, so square root of 81 is 9. Then down at the bottom we have right in exponential form, we have the 5th root of a, so a to the 1/5 as an exponent, and the 6th root of x would be x to the 1/6. Now, our law of negative exponents says that any time we take a base and an exponent and drop it to the numerator, it will switch the sign of the exponent. So if I have 49 to the negative 1/2, before I start multiplying or working anything out, I want to apply the law of negative exponents and make this 1 over 49 to the 1/2. Well, 49 to the 1/2 power is the square root of 49. The square root of 49 is 7. So I have 1/7. Applying the law of negative exponents and radicals. Let's look at our pattern for fractional exponents. We have the numerator on our exponent is the power, and the denominator on our exponent is our root or index. So the y that's the denominator is in radical form, that is your root or your index, and the x that's the numerator is going to be the power on your base. It is your base or the exponent in the radicand. And that would also apply if it was outside of the parentheses as your exponent. So if you don't have this written down, this would be key to write down for this concept and be able to recognize this pattern of a to the xy is the y root of a to the x. So write each expression in radical form. So if I have 32 to the 2/5 power, well, the denominator is always the root, so I have the 5th root of 32, and the exponent is 2. So the numerator is the exponent. X to the 3/4 power, if I change that to radical form, I have the 4th root of x to the 3rd. The denominator is the root or the index, and the numerator 3 is the exponent. A to the 6/5 is the 5th root of a to the 6. What if we're given radical form and we're asked to write it in exponential form? We're going to go backwards from how we started. This time I have the square root of 15 to the 3rd power. Well, I'm trying to figure out, I know 15 is my base, I'm trying to figure out what my exponent would be. And when I go to look at my root, I don't see a number there. Well, square roots are so common we don't always write the 2. We can if we want, but we don't have to. So in this case, I have the square root of 15 to the 3rd power. So is this going to be 15 to the 2/3 or 15 to the 3/2? Well, the root is the denominator. So the exponent is 3 is the numerator. The root, the square root, means we have 2 for the denominator. The 6th root of 3 is 3 to the 1/6. The 4th root of a to the 7th, we have a to the, and the denominator is 4, the numerator is 7. The root or index is the denominator, and the exponent is your numerator. All right, let's look at some operations we can do with these, and these rely on all our exponent rules. The exponent rules and the radical rules all fit together nice and pretty and are mathematically beautiful how they all work, lots of different paths to the right answer. So right here we're multiplying. Notice how the sign in between is a dot, meaning we're multiplying y to the 1/7 times y to the 4/7, and we multiply and have the same base, so we want to add the exponent. So I get y to the 1/7 plus 4/7 is y to the 5/7, and y to the 5/7 is equivalent to the 7th root of y to the 5th. The next one I have x to the negative 2/3. I have a negative exponent. I want to apply the law of negative exponents, drop it to the denominator, drop that base and exponent to the denominator. Notice how our sign is now not negative 2/3, but it's positive 2/3. Then I can rewrite that as an equivalent radical as 1 over the cube root of x squared. What about 3x to the negative 1/2? Oh, I see that negative sign again. Let's apply the law of negative exponents, drop everything to the denominator. Then I have 3x to the 1/2, and I'm starting to see every time I see something to the 1/2, I recognize that anything to the 1/2 is square root. So I have 1 over the square root of 3x. 15 to the 1/3 times 15 to the 1/3. I am multiplying, have the same base. Multiply, have the same base. We can add exponents and get 15 to the 2/3. And to write in radical form, the 3, the denominator, is the root or index, and the 2 is the exponent. So I have the cube root of 15 squared. How about simplify each expression? We have 9 to the 2/3 times 9 to the 1/3. Multiply and have the same base. We add the exponent. In this case, it's nice. We already have a common denominator of 3, so I can add 2/3 and 1/3 and get 3/3. 3/3 is the same as 1, so 9 to the 1 power is equivalent to 9. Anything to the 1 power is just itself. All right, you guys try the video, pause the video here, see if you can try this problem, see how you do. This is a tougher one. Think about those exponent rules. We're dividing and have the same base. Pause, come back, see how you did. Well, when we divide and have the same base, we subtract exponents. So I want to subtract 3/4 minus 1/8. Divide, have the same base, we subtract exponents. Now, if I'm subtracting 1/8 from 3/4, I have to have common denominators. So I need to know that 3/4 is the same as 6/8. Then I can subtract 6/8 minus 1/8 is 5/8, and x to the 5/8 is equivalent to the 8th root of x to the 5th. So those exponent rules don't go away. Divide and have the same base, subtract your exponents. All right, you guys pause the video here. Try this one, x to the 8th times 1/2. All right, welcome back. So when I'm multiplying an exponent to an exponent, you just multiply 8 times 1/2 and get x to the 4th. Or if you just recognized anything to the 1/2 is a square root, we could also do it like that. We could do the square root of x to the 8th. Square root of x to the 8th is x to the 4th, because x to the 4th times x to the 4th is x to the 8th. Both of those rules work to give you the same solution. All right, how about this one? This one confuses people because we have addition. This is not the multiply and have the same base, add the exponent. This is addition. So 7 to the 1/2 plus 7 to the 1/2 is like having the square root of 7 plus the square root of 7. And when we're adding and have the same radicand, we have radical 7 plus radical 7, the 1 plus 1 in front adds, and it stays with that common radicand of 7. So 1 radical 7 plus 1 radical 7 is 2 radical 7. So I hope that helps you guys with your radicals and rational exponents. Have a great day.